Hello everybody and welcome to today's webinar, OpenEdge TechTalk on resilience and security. This webinar will be presented by Stefan Bolt and we will open up for a live Q&A at the end. Over to you, Stefan.
Hello and welcome everyone, and thank you for joining our next webinar in our OpenEdge TechTalk series. My name is Stefan Bolte and I work as a solution engineer with Progress for over 25 years, based in the Cologne office, currently working from home. I'll be talking you through OpenEdge resilience and security today and how it can help you in hardening your deployment environment to meet today's application uptime requirements. Last time around, we've talked about continuous integration and continuous delivery. Continuous delivery allows us, on the one hand, to get closer to an always online deployment with very high percentages of uptime. But that goal, on the other hand, requires us to set up a very resilient deployment. And today, we will explore the OpenEdge resilience features, including OpenEdge Replication. So let's have a quick look at the agenda for today. Let's first understand what is resilience and security and why it matters. With OpenEdge 12, you now have a wealth of features at hand to maximize uptime and resilience of your production environment. Then let's take a closer look at OpenEdge Replication, which is one of the core features improving resilience. Now without further ado, let's get started. So what is resilience and security and why does it matter? There are a couple of definitions. Here's one by Google. A resilient app is one that continues to function despite failures of system components. Resilience is a matter of the whole application, not just the database. And resilience requires planning at all levels of our architecture. It influences how you lay out your architecture and how you design your application. Building and operating resilient production environments is hard. This is especially true for multi-tier apps, which might contain multiple layers of infrastructure, of networks, of services. Mistakes and outages happen, and improving the resilience of your environment is an ever ongoing journey. With careful planning, you can improve the ability of your OpenEdge production environment and your application to withstand failures. And with proper process and organization culture, you can also learn from failures to future increase the overall resilience. A lack of resilience causes an excessive number of failures. This is a list of examples of causes an administrator will want to not experience any of these. The user's view, however, is different. The user expects the business applications to be available without any downtime at his business hours, regardless of whether accidentally or scheduled. And it's not just black and white, system down or up. Poor performance and high latency affects the user as much as a downtime. So the baseline is a resilient deployment aims to avoid any of these situations which would impact the user's work. We all know stories of OpenEdge deployments which run seamlessly without issues for years. And that's great. And hardware and software is more robust than ever. Well, that's true for cars as well. Still, we fasten our seatbelts while driving, and we take out an insurance before an accident occurs, while not expecting any accident. So we prepare for the unexpected since we need to avoid the damage. And there are a couple of reports and analysis that show that costs of an outage continue to rise. Here's just 2 links, and you might want to check it out yourself. I recall a customer situation 2 years ago. Their production system was down for more than 48 hours. It all started with programming mistakes, and nightly batch jobs took too long to finish in time. Administrators didn't know how to handle this situation, and applied wrong and risky measures, such as killing self-service bad jobs. Eventually, this affected the consistency of the database, shared memory, and caused emergency shutdowns. The transaction scope was wide, and the rollback took too long. They killed the rollback, and they just made things worse. Then they hit a bug with corrupted indexes of the OpenEdge 10 database, and the database finally stopped working on the 7th day at noon after the issues first appeared. They did not have an emergency procedure. Should they try to rebuild the index? Should they restore a VM snapshot? They tried to restore a snapshot, but that turned out to take too long as well. Eventually, they had to restore a database backup, redo the user work of the last morning. Well, this customer is a wholesale company, and they could not sell a single item for more than 2 days. This is an example of a catastrophic situation where a chain of mistakes happened, ownerships and roles were not defined, and administrators were not prepared and experienced. It boils down to designing resilience and proper preparation. By choosing a resilient production architecture, you're not just hardening your system and your setup and reducing downtime, but also avoiding human mistakes in case of a system failure. And beyond that, you are forced to verify the setup and prove it will work as expected in case of an emergency. After this exercise, you will not be caught by surprise. Best practices include elimination of single points of failure, assuring reliable crossover, and detection of failures as they occur. Planning for resilience includes application design principles, such as using stateless mode for services, as well as supplying redundancy for load balancing and failover. Some of the listed components on the right hand are provided by OpenEdge, for example, the Progress Application Server for OpenEdge Health Check and the OpenEdge Replication feature. So let's look what features help to achieve resilience with OpenEdge 12. With OpenEdge 12, we aim to provide an OpenEdge platform which supports an ever-growing number of deployment options, physical, virtual, and in containers, on-premise, hosted, and on a cloud platform, which is more scalable and performant than ever, and which eventually will help you to deliver a higher percentage of uptime. With OpenEdge 12.0.1 and .2, we delivered a wealth of features helping you to increase uptime as we support key operations with the database and application online. Reorganize database areas online, add and activate indexes online. Increase the size of the buffer pool or log table online. Add or rename database fields online while the application is running without the need for recompile or restart. Update the application R code and have the app server agents reload the new R code dynamically without restarting. Deliver the application in a Docker image, allowing you to scale or update your application while being online. Or use OpenEdge Replication to have a hot standby database. We introduced a new after-image replication queue mechanism, which is more performant and resilient itself. But let's focus on resilience. The basic OpenEdge ingredients of resilient setup are setting up multiple Progress App Servers for OpenEdge App Server instances, having a hot standby database, and configuring the app server agents or GUI clients in case of a client-server application with auto reconnect and an alternate database reference, which is the hot standby database. The client requests get routed by a load balancer, and the system gets monitored by OpenEdge Management or, for example, a monitoring system, New Relic. We provide a plugin. This diagram looks very much the same, but there are additional components required in a cloud deployment. In the middle of this graphic between the clients on the left and the OpenEdge application on the right side. In such an environment, you would add additional security layers, such as a demilitarized zone with firewalls, proxies, routers, and the OpenEdge authentication gateway providing centralized user authentication accessing external identity providers. And again, this diagram looks very much the same, except for the OpenEdge stack is now deployed into the Amazon Web Services. Availability is now deployed into 2 Amazon Web Services availability zones with elastic load balancing and auto-scaling groups. We have created an OpenEdge AWS Quick Start package, which helps you to set up a resilient OpenEdge production environment in the AWS cloud. The infrastructure is described as code and can be set up by a script. See the OpenEdge Quick Start Guide document for more details, the second link on this page. Basically, we apply the best practices of OpenEdge resilience in the cloud by providing a quick start script. At the database layer, again, we have a hot standby setup with automatic failover. The hot standby DB is kept in sync using OpenEdge Replication. OpenEdge Replication is key to providing resilience at the database layer. So let's take a look. But first, you need to back up your database scheduled and frequently. No exception to this rule. Full or incremental, online or offline, with Pro Backup or any third-party tool, that's up to you. But you must have a backup. Replication or SAN mirroring does not save you in case of, for example, sabotage or unintentional purging of records. And database corruption on the file system gets mirrored as well. In either case, you need the option of reverting to a valid backup of your database. Okay. OpenEdge Replication allows you to have up to 2 hot standby databases. It copies the transaction log after image nodes to the target server and applies these nodes continuously into the target database, thus providing a database always in sync with the source DB and always online for fast failover. OpenEdge Replication Plus adds the option of using the replicated database as a reporting database. You can access that database by ABL or SQL in read-only mode, supporting your reporting tools of choice and reducing the load at the source database. By the way, OpenEdge Replication is a feature of the OpenEdge Advanced Enterprise Edition. Using database replication is the best way to make your application continuously available and fault tolerant. If for any reason your production database machine, the database or network becomes unavailable, you can quickly transition to the replicated database. OpenEdge Replication provides near real-time replication of an OpenEdge database from one location to another. The second location can be local to the production database, at a remote data center, or in the cloud. OpenEdge Replication requires a minimum of 2 databases, a source database and a target database, or a primary and a secondary database. The source database is where the users do their work and make database updates. This database is the production database and has both read and write access for all processes. The criteria for an OpenEdge Replication source database are: after imaging is required to be enabled on the database and is used to capture all database activity. The source database must be enabled as an OpenEdge Replication source database. The target database originates from the source database by an initial full backup and contains the same data and schema as the source. The target database does not allow database updates by anything other than OpenEdge Replication agents. And as already mentioned, OpenEdge Replication Plus permits queries and reports by users connecting to the target database. A replication set is a two-target replication as shown here. This is where the two targets are aware of each other and are configured to continue replication in the event of a server failure. Adding a replication set to an OpenEdge replication configuration changes the failover activity. The goal of the replication set is to minimize the risk of a single point of failure and the need to rebase. With such a replication set, if a replication agent loses communication contact with the replication server, for example, if the primary machine were to shut down unexpectedly, you can move all the database update activity from the source database to one of the target databases, and the other target becomes the target DB to the new source. Okay, but is the effort of setting up OpenEdge replication? What's the effort of setting up OpenEdge replication? Wasn't it known to be complex and somewhat cumbersome? The answer was yes, and we improved the whole process of setting it up, as well as falling over and falling back, since we introduced this feature in Progress 9 20 years ago. Today, setting up an OpenEdge replication is a straightforward process, which includes creating the target database structure and applying a backup. Of the source DB. The source database needs to get after imaging enabled. The databases get then enabled for OpenEdge replication using pro-util database name -c enable site replication and the role of that database. You configure the replication setup in a replication properties file. With OpenEdge 12.2, we provide enhanced syntax and consistency checking, which supports you in editing the properties. The documentation provides details and options and guides you choosing the settings. Well, this diagram shows the normal operation state. Transactions are replicated continuously to the target or the targets. The user app server agents are connected to the primary system. Now a failure occurs. The primary system becomes unavailable. An application monitoring system such as OpenEdge Management detects the outage and initiates the failover to the secondary database. This may also be initiated by a defined timeout of the replication agent on the target DBs. The target DB becomes the active database, or the primary, and clients can reconnect to this standby database. If you have set up a database set, that is, you have two replicas, the configuration after failover still has two databases, one of which is the new replica. And all of these transitions, including future fallback or recovery transition, are performed while the databases stay online and available. With OpenEdge 12, we introduced a new streaming replication architecture, now buffering the afterimage nodes on the target machine in a replication stream block queue. This reduces the load on the source DB side and accelerates the failover process significantly, multiple times by our own tests. With OpenEdge 12.2, we also made sure that the database brokers stay online at any transition between the replicated databases, failover and recovery transition. No downtime is required. Now, in case the system fails over, how does the client or app server agents reconnect to the secondary database? With OpenEdge 12, a client connects to the source and has an alternate database defined by its connection parameters, which you see on the right. When the client loses the source or primary DB, it will try to reconnect, will fail again, and go to the next DB on the list if AutoConnect is set. Otherwise, the client must reconnect manually, which is start over. In this case, it will still connect to the alternate DB, but it won't be automatic. Well, you might wonder, wouldn't my after image roll forward do the job? Wouldn't my snapshot provide the same safeguard? Would my storage area network with its hardware mirroring capabilities do the job? Well, while all these technologies might propose being an element of your backup strategy, it does not help you to avoid downtime. Restoring a backup or a snapshot takes time, and by our experiences, we talk about hours while your system is down. With OpenEdge Replication and with a stateless application, a user would not even experience any change in system availability while the database falls over to the secondary database. That is resilience by the user's point of view. Here's another benefit of using OpenEdge Replication. It allows you to update the OpenEdge installation while your application stays online. Since there is now support for replication across databases running different minor versions of OpenEdge, the target can now connect and synchronize with the source after updating to the new version. Also, we can now failover transition to the migrated target after updating. From this, we can allow client activity on the updated target, now acting as the temporary source DB, while upgrading the original source database. And later on, we can fall back to the original source database. Baseline, the application is continuously online during an OpenEdge update. How cool is that? Well, summary. I would like to summarize the key points of this session. We ensure resilience by applying best practices when setting up the production system architecture with redundancy and automatic response to failure events. This helps to ensure instant response to any event and avoiding human mistakes in a stressful situation. With OpenEdge 12, PaaS for OpenEdge, and OpenEdge Replication, we have all required components at hand for implementing resilient deployment environments. Check out the links which we have provided with this webinar. It will help you get started with some of the introduced concepts and take advantage of the experience of our professional service teams, which can share their experience to get you up and running even faster. I'd like to mention one other webinar. My colleague Marv Stone addressed data encryption in addition to replication. You may find this webinar valuable as well. The link is below and it's available in our webinar area on our website. There are a number of resources available for you to help you get started or to find the detailed documentation, and I find these resources helpful for getting started with OpenEdge high availability and resilience. And to conclude today's session, I'd like you to refer to our series of on-demand webinars at progress.com webinars.